Alright guys, today we're going to be talking about ratio tables, but before we start I want to do a little review, and I'm going to be doing just a little bit of review because we're going so quickly. So today, as I ask you to think about questions, make sure you pause and really think about it, because that's how you're going to really move it into long-term memory. So first, I'm going to take this little stopwatch, hopefully you can see me, and I'm going to time myself. So I'm going to compare two things. I'm going to compare time to how many times I can click my tongue in 10 seconds. Ready? So let's see. How many clicks can I do in 10 seconds? Ready, set, go. I forgot to count. Did you count? I think it was 22. Was it 22? No, it was, let's just say it was 30. 30. So, oh, that dead pin. That was 30 clicks of my tongue in 10 seconds. So what is that? Is that a ratio, a rate, or a unit rate? So pause and think. All right, you thought about it. What is it? Well, it's not a ratio because it's a specific, well, there's a better answer here. The most precise answer wouldn't be ratio because it's not just comparing it's not comparing units that are similar. It's actually comparing two units of different, what? Comparing two quantities of different unit types. See how this is clicks to seconds? Very different. So this is actually a rate. All right, well, what if I was to do this? What if I was to divide, I wanted to get the denominator or bottom position down to 1, so I divided both by 10, or big 1, and I got, for every 3 clicks, it took me a second. What's that? Which one best describes that? Think about it. All right, if you said unit rate, you would be right, because unit rate is where you take your rate and you simplify it down to when the denominator has a 1. In its denominator position. All right, good. So let's try this one. And just because I'm going to, just because ratio is the only one left, doesn't mean it's the right answer. All right. So I look into this. I was thinking about my classroom of last year, and in my class there were 12 girls for every 6 boys. Ratio, rate, unit rate. What best describes it? Think about it. You're right. It would be a ratio because these are similar types. They're humans. And so this would be a great example of a ratio, unit rate, and two different types of units, rate. Really important you know the difference in that. That leads us into our lesson on ratio tables. But before I do that, I want to show you something here. Let's see if I can do this without making you sick. Here on the table, I'm going to build a ratio. So I'm going to be comparing two things. Here we have, for every 3 blue rhombuses, we have is that a hexagon? How about 3 blues to 1 yellow? Now, let's say I want to build that ratio. So what would my ratio be then if I have 6 blue shapes? Well, it would have to be 2 hexagons. 1, 2, 3. Right? What if I had, I'm going to run out, 3 sets of 3 blue rhombuses? Well, then how many yellow hexagons would I have? You're right, it would be 3. And this would be called extending my ratio. See how I have, for every 3 I have 1? Okay, well, obviously if I double it, or every 3 I have 1, every 3 I have 1. And then here, if I extend it one more time, it's 9 to 3. But look really closely. You see how they're all made up of this basic, fundamental, simplified ratio? You see how you always see the 3 to 1? In fact, if I was to extend it further, I could make it look like this. Right? I could make it look like that, and that would still hold true. Now, why am I showing you this? I'm trying to give you a very concrete example of a ratio and me extending it. All right? these are fundamentally, if you simplify them, the same ratio. It's just been expanded. And so the question becomes is, when you start looking at ratio tables, I might remove that and say, well, how would I get from this position to that position? What would I have to multiply by? And that's what we're going to be talking about today. Or maybe I might ask this. Maybe I might ask, this might look more complicated. How can I get from a ratio of 6 to 2 to 9 to 3? How can I do that? Whoops, let's get that out of there. And what you're going to find is that there's going to be a couple different ways. One might be simplifying this into its most simple state. And then saying, oh, multiply by 3/3. That might be the one way. And so that's what we're going to talk about today. And so let's go back up to the screen. How can we extend and work with ratio tables? All right, so tables are a nice way of showing what I just showed you with objects. Some of you might be like, oh, I prefer objects. And that's okay. So let's take a look at this ratio table. Let's say I have yellow to red beads. And sometimes it's really easy to see. So you might see there's 6-to-1 ratio. And then I know that I have 5 reds. Well, if the ratio stays true, how many yellows do I have? Well, you have to think about, well, how did I get from here to here? And it's always through multiplication or division. Well, I multiplied by 5. And so therefore I must multiply the top by 5. And I would get 30. Now that is pretty much the easiest way, because if you look at that, that's a unit rate. And therefore I can pretty much manipulate it any way I want by multiplying. Because for 1 times whatever I want to get to allows me to get there. Let's take a look at this one. So this one's a little different. What if I have, let's see, hot dogs to burgers, and it's a ratio of 66 to 12. 66 to 12 to 2 to 11 to 2. There are multiple pathways to get here. How can I get from here to here? Personally, I think it's always easiest, since it's decreasing, what did I divide by? Can I divide them both by the same number? Yeah, I can divide by 6. See that? I can divide by 6 to get there, and and I made a silly mistake. Sorry about that. It's still true. What's silly is I made a dumb mistake. How? If I have 66 hot dogs and 12 burgers, then how many hot dogs would I have if I had 2 burgers? Well, the question is, what did I divide by to get there? If I'm decreasing, I'm dividing. So I divide by 6. Whatever I do to this part of my ratio, I must do to this. And so I would divide by 6. 66 divided by 6 is 11. So if there's 2 burgers and the ratio holds true, then there will have to be 11 hot dogs. You see what I'm doing? I'm basically using big 1 of division or multiplication to basically scale up or down my ratio. Let's try another one. Let's try, how about this one? 10 to 4, oops, and this is 15. And we're comparing, how about we're comparing, in my pocket, pennies to dollars. And in my pocket, for every 10 pennies, I have $4. All right, well, if that ratio holds true, what if I have 15? Now here becomes the challenge. What if I have 15 pennies, and how many dollars do I have? Well, here becomes the challenge. How did I go from here to there? And so there's many ways of thinking about this. Here's one strategy. You see how these are multiples of 5? Okay? So what if I could get this down to 5? Because if I can get this to 5, then I can multiply by 3 to get to 15. Well, how did I go to 5? I divided by 2. So then I must divide the other part of my ratio by 2. So if I have 10 pennies, I'll have $4. Or if I have 5 pennies, I'll have $2. Well, then how can I get to my final destination if I have 15 pennies? Then, well, what did I do? Multiply by 3, multiply by 3, and I get 6. So for the ratio to hold true, if I have 15 pennies, then I'll have $6. But do you see what I had to do? I had to look into the, kind of look forward and strategically think. How am I going to get from 10 to 15? And for scaling to work, it's the same as fractions. You must use big 1. See how I use 2 over 2, 3 over 3? Those are the same as 1. You must use those to get there. Let's try a few more. All right, let's go to page 42. All right, we're on page 42 now. Let's take a look at number 1, numero uno. Allowance to weeks. So I'm going to have A to W. Here it is. And I'm having marker failure. And in week 1, I have $7 of allowance. Right? What will I have in 4? All right, will you pause it and try that? All right, well, that's not too hard, right? How did we go from here to here? Well, we multiplied by 4. Therefore, we must multiply the top position by 4. And in 4 weeks, we'll have $28 of allowance. All right, let's try another one. Let's try number 2. Here we have 8 to 60. That's our ratio. And what are we exactly comparing? Because that's what a ratio is. We are comparing kilometers to minutes. So let's think about that. Is that a ratio or a rate? Pause and think. All right, hello? It's a rate. These are 2 different types of units. Measurement of distance and time are different. All right, so if I can run 8 kilometers in 60 minutes. Therefore, how long will it take me to run 2 kilometers? Well, how did I go from 8 to 4? And remember, you don't have to use all these slots. They're just suggesting it. I'm going to divide by 4. Therefore, I must divide the bottom position by 4 then. So the answer isn't 2:15. Since in 15 minutes, I can run 2 kilometers. All right, let's try another one. Let's move to number 3. And this is a word problem, so I'm going to have to be careful how you do it. La Mica buys 12 packs of juice, all right? So this is juice. What are we comparing that to? 12 packs of juice boxes that are on sale for $48. That's very expensive. Use a ratio table to determine how much La Mica will pay to buy 8 more packs. So 8 more packs would be 20 packs. That's kind of the tricky verbiage in there. So how much did it cost for 12? $48. Well, to buy 8 more, that means we have to count up 8 more. That's 20. How do I get from here to here? Well, I want to get it to a multiple of 20. So what if I divide it by 3? I'm going to get 4. Is 4 a multiple of 20? Yeah. So let's divide the top and bottom by 3 over 3, which is the same as 1. So 12 divided by 3 is 4. 48 divided by 3 is 116. Now, is there a pathway to get to 20? Yeah. Multiply by 5. So 5 times that is 50, plus 30 is 90. The answer is not 2090. The answer is I can get 20 packs of juice for $90. That's a lot of money. There must be like gold in there. So guys, remember, you must find a pathway to get there. And you might be thinking it totally different than me. Whatever you do, show your work. Show me your pathway. You should be putting these, and then make sure you're studying these. Please watch your videos daily, just so you know. Test when you come back on this unit. Study, and bye-bye.